I call this solving multiple triangles because, yeah, sometimes we use the right triangles as well to solve. So far you didn't see that, but I'm going to just add another small layer to this. Nothing you cannot handle. Okay, so something to remember. These are steps that I recommend. Fill in what you can tell without solving, right? Use complementary or supplementary angles if present, okay? Start the triangle with the most information, right? If you're worried, like, which triangle, there's so many, which one should I start with? Start with the one that has the most info, like a side, a bunch of angles. Like, that's the one I would start with. Solve for the side that is shared between the triangles. I'm not so sure if this is necessarily a must, but it definitely will help you if you do that. It will be faster. Now solve for the sides required to answer, obviously. So some of you need steps. I don't think I necessarily follow them. I kind of it just flows after a while. You'll know you have to do those things. Okay, so here we go. First question. The angle of elevation to the top of the tree to point B, from point B is 42 degrees. Let's go check it. It makes sense, right? This is definitely an angle of elevation. We got that. From point C, which is 70 meters closer to the tree, here we go, right? We go 70 meters closer. There, your angle of elevation is 58 according to this question. Okay, we got that too. So that's this one here. Check. How tall is the tree? Right, so we're trying to figure out the height of this. This is our ultimate. We want to know that. Okay, so we would start with this triangle. I would argue we should start with this triangle here. Okay. Do you see a supplementary angle there at all, or two angles that add up to 180, a straight angle, whatever you want to call it? You should see that at this point you've got two lines here that make a 180, right? So we have this happening here, right at that intersection. So if this is 58, we can easily find out this one right here. So you can just grab your calculator. Honestly, if it doesn't ask you specifically to solve for it, you just do this on your calculator. So two angles add up to 180. So this means that this is 122. Okay, so I went 180 minus 58 to get the 122 there. And this should be a ripple effect. Now that you have the two, you'll find the third one up here. This is a triangle, so all three should add up to 180. So I will just go 180, sorry, I'm blocking, I know, minus 42 minus 122. Right, so you grab your calculator, subtract what you've got, and that's 16 up there. Okay, so you've got 16 degrees up here. So this is step number one here. That was my first step. Then I moved on to more angles. Once you get angles, it's just angles, angles, angles. Okay? You found that, right? We're good? What can you use to solve there? It's hard to see the pair, right? It is. But this 16 is across this side 70 here. That is a pair. Okay? You can't use cosine law. As much as you love cosine law, you can't. Side angle side, right? That would require at least two sides. You can't use that here. You only have one side. Side, side, side would be the other candidate. Not even close, right? So you can't. You have to use sine law, but don't use sine of 42 over 70. They're not opposite each other. Okay, so we're gonna go and solve. We're gonna use sine of 16 over 70 meters. And which side do you think I will solve for? Because you have a choice. If you use 122, you're gonna solve for this one. If you use 42, you're going to solve for this pair. Like this literally is a pair as well, but this one is unknown. I'm going to call this x here. That's what I will solve for. Okay, so that means that I have to take sine of 42 degrees to solve for side x. I solve for the shared one. So cross multiply and divide. Okay, so when you cross multiply and divide this, oops, my bad, 70, right? Times sine of 42 divided by sine of 16. Come on, I can do this. Sine of 16. That's 169.9303. I'm just going to use 4 decimals. Why 4 decimals? Because I'm not there yet, right? Like this is not a question that does A is this, now find B. We're still on our journey. So this is going to be in meters. I'm doubling my decimals here. Okay? So this is one chunk here that I had to figure out. Okay? And that's this side right here. You like highlighters? I like highlighters. Okay, so I've solved for the one that is shared. Shared between what? Between this triangle and that triangle, right? These two triangles share that side. Now I have this right triangle, which will allow me to inch closer to this. I'm going to call this height. Okay. Do you have a pair in this one? Well, I don't know. What law would you use? I'm going to sketch it out here. This is the one I want. I have this. This angle here, the 58, that used to be irrelevant to me. I mean, it helped me, but I didn't use it in any of my calculations prior. This is not going to help me find that. So you have your pair here, and that will allow you to solve for that. So it is sine law again. If you didn't use 4 decimals while you were doing this, don't worry about it. You now know for next time. Make a note, right? Sine of 58 over h, like that. So cross multiply and divide. Fun stuff. Anybody remember what sine of 90 is? It's just one. Uno, right? There you go. $144.11 if you round it to 2 decimals. Meters? That's a tall tree. Whew. 144 meters. I probably just made up the numbers and that's why. It could be. I'll look it up. It seems quite tall. This is your ultimate answer. That one you get to round to 2 decimals. Okay? So there we go. If you want to, I always like a bit of a flow. Like where did I use that number here, right? And then it just continues. So that's how you work with multiple triangles. Just make sure you don't mix. You're listening, right? Because I know I can put you to sleep with my voice sometimes. Don't mix up triangles. So I will sometimes see sine of 16 over 70, sine of 58 over h. They're 2 different triangles. So make sure you check, okay? Am I mixing up triangles? Because sometimes it's too good to be true, right? So, because it happens, but don't fall for that. Okay, let's keep going. One more. I'll do 39. And then I'll give you the quiz. So if you want to get started today, sure. This one is very similar, so I'm wondering. Actually, now I'm wondering if I'm just gonna let you do this one and do one that's a bit more challenging. I'm gonna skip to 42, okay? This one is basically the same idea that we just did. So let's go to 42. What in the world is happening here? There will be one like this on the test, okay? So that's why I'm telling you, let's go to 42, okay? So if you want to say, this will be on the test, Mr. Dirksen said so, you can do that right now. This one isn't the greatest, this is too dark here, but you just got to make sure this dashed line, there's a 90 formed at the base here, so it's not quite clear. But make sure that dashed line goes all the way down. So the idea is that this building is on top of a hill, and let's see what we can do. I'm going to use a different color for the things that I'm adding, okay? So let's see here. Calculate how high the building would be above the ground. So determine the total height of the cliff plus the building, okay? So our ultimate goal is to figure out this. So this is height. So once we figure out this, we're going to add the 30 to it to figure out the total height of it. Okay. So how would you do that? There are several ways. I just want to make an observation here. If this is, I'm going to use highlighters here because it's very important that you get this. If this is 58, okay, then how would we, or what would be the measure of just this little sliver here? Maybe you see it, maybe you don't. But we know that it's 64 all the way to the top line, right? And it's 58 just here. So I can find this angle right there by going what? 64 minus 58. Okay. So that little sliver is 6 degrees. Yes, you heard it right. It doesn't happen very often that we have small angles like that. But that little thing is 6 degrees, so you can fill that in if you want. So technically, folks, the 64 now becomes irrelevant. Like you can, well, because the 58 and the 6 add up to the 64, so you just got to make sure you keep that separate. So 58 for this, 6 degrees for that, 64 for the whole thing. Okay, so complicated there at that corner. We know that this is 90. Okay. Could we figure out this angle here? Look at this triangle. We've got 58 there, we've got the 90. We could figure this one out. Sum of triangle, right? So I'm going to go like this, arrow into it, and I'm just going to go 180 minus 90 minus 58. And I'm going to highlight that 58 like that. That would be 32 degrees. So as you can tell, once you find a bunch of angles, it's a ripple effect. You can kind of figure out everything. Sum of triangles equal to 180. Oh, I gave it away. I shouldn't have put this here. BAC, right? It's this angle right here. Do you see something right here? Does this look like a hat to you? It's just sideways?
Oh yeah.
Hey, let me try this. That's what you're used to, right? These two, there's a straight line, right? They add up to 180. So that is 148. Oh my goodness. Stop breaking our brains here. This is 148. They add up to 180. I gave it away here. I need to take this out next time. What's this one here? 180 minus, this is a triangle, correct? You're seeing this? Weird triangle here. So I'm going to go minus 148 minus 6. Okay. And that gives you, I don't even know if I need all of this information, but I just want you to see it because I could ask. 26 is up here. Okay. So you have all the angles that could possibly appear, they're all there. Do you need me to zoom in or what? Make sure you write them all down. Just in case, I haven't used green yet, so you're not confused like what's up with this. It is this angle right here. I got 58 from here. Does that make sense? 58 gave me that because I subtracted, I used sum of triangle for this one. How would you start this? Any brave volunteer? Which triangle has the most information? I would argue this one here, because you got the 30, right? This is 30, and you got a bunch of angles. So 30 is across which angle? The tiny one here. These are across. So you would start with, let's sketch it out here. Doesn't hurt. I'm going to put the 6 in there, the 148 in there, and this one is 26 up here. And I know that this is 30 meters. Okay. So we're going to go sine of 6 degrees over 30. And then which side should we solve for? Because I won't tell you. You have to determine. This is the one that's shared, correct? This one here is shared between this triangle and that. So that's the one I tend to pick. So I'm going to call this X here. And you can call this one X here. That's the one I'm solving for. So which angle would I pick? You can whisper it. 26, right? 26 is across this one. So sine of 26 over X. And there we go. I don't want you to forget to solve for angles using sine law. But right now we're doing other problems. We have enough problems, right, to worry about that right now. So 30 times sine of 26 divided by sine of 6 is 125.81. So but I need to redo this because I have to use 4 decimals. 8139. This is important, but not yet the ultimate. I need a color that I haven't used yet. I'm going to use this one is this side, which and the big one here is this one. It's getting too crazy, right? Yeah, I know. We're not done yet. Now I'm going to fix my attention to this one right here, the right triangle. This right triangle here, I'm going to zoom in on this one. So I'm going to copy down as much information as I can to it here. What's this one here? This is 58. It's that orange one. Yeah, I feel the same. 58 over h. I know this side. This is 125.8139, the one I just found. And I'm gonna go sine of 90 over 125.8139. Don't be thinking it's always sine law now, okay? It's not always gonna be. Sine of 58 over h. You cross multiply and divide. Just make sure you write this down. Why did I pick the heart one on a Monday, right? I know. You cross multiply and divide, you get 106.69. Let me just do this again. Here you go. 106.6962. Why am I still rounding to 4 decimals? Because I'm not done. What does it ask for? The height of the top of the building to the ground, right? So total height would be this one that I just found plus the building itself. Come on. See, even the computer said that's enough. There we go. It's 136, and now we can round. This rounds to 70, right? A few meters. There you go. That's the final answer. Will there be so many crazy ones, like a bunch of steps? Not a whole lot. Usually it's 1 or 2 steps, but this one takes it, gives you probably the craziest scenario, okay? All right, I will post, maybe I won't tell you which pages I'm gonna post just yet. I'm just gonna leave this in your notes. You're gonna worry about the quiz.